Hi again, guys. Here's the next part of your activity for today, for Monday. So I have this like already done so that I wasn't trying to hold it with my elbow and shake the camera all over the place while I was recording. So I'm just going to walk through what I did here, and you are going to create something similar on your paper at home. Again, I have plain white paper. You could do this on grid paper or lined paper. It's fine. I just chose plain white so you could see better. So the first thing you need to do is create a polygon. I chose a quadrilateral that has 4 vertices, and then I used my straight edge to connect them. So this is my original QRST. You could do a triangle, pentagon, hexagon, and make it as fancy as you want. You'll notice, like with my finished product, about what size this is. You'll notice about what size it is because I'm going to enlarge it and I'm going to decrease it. So I don't want it too big. I want the enlarged version to still fit on my paper. I don't want it too small. I want the decreased, the shrunken version to also fit. So once I have these points, I then used my straight edge to create, I put a center of dilation off to the side somewhere. And then I used my straight edge to connect a ray that went from my center of dilation through my original points and out, extended out through each point. Nice and far. Actually, some of them I didn't make far enough, and then I had to go back and add more later. So go ahead and just like extend it even like to the edge of the page if you want to. Okay, then we're going to use a scale factor of 2 for the next part. And that means, just like with our individual points in the first video, you're going to measure how far from the center of dilation to your original point, and you're going to double that distance and put a new point. Except you're going to do that with all of the points from your polygon. So maybe a triangle is a good choice because then you only have 3 points to dilate. So you can see like Q prime is twice as far from the center of dilation as Q was. And R prime, same thing, twice as far. S prime, twice as far. T prime, twice as far. I didn't connect these, but you are going to then go on your own paper and connect these points using your straight edge so you have a larger version of this figure. You've dilated it using a scale factor of 2 and a center of dilation of P. Finally, you are going to dilate again using a scale factor of 1/2 and using a center of dilation of P. So this technically isn't correct that I call my enlarged version Q prime and my smaller version Q prime, but we haven't learned how to address that situation. So for now, they're both Q prime. So I'm gonna again take this measurement from the center of dilation to Q. I'm gonna cut it in half. I'm gonna cut that measurement in half. Either fold my note card in half or use my ruler, divide that measurement in half, and put same thing for point R, for S, which happens to be on the same line. I didn't even do that on purpose, and T. And then I'm going to connect those as well, which again, I didn't do, but you'd want to use your straight edge to connect those. So you have 3 versions of the same figure on your paper, a small, a medium, and a large. And you're going to bring this paper also back to school with you when you come in on Tuesday.